Okay, thank you very much. And yeah, I wanted to talk about making our systems more maintainable, readable, easy to reason about, easier to test, and things like that. And I will use asynchronous system as an example, badly written asynchronous system as an example. So the system that uses futures mostly, and I will try to show you how what kind of refactorings can we do in order to make the system more maintainable. And sorry for the slides not being full screen. There are some technical problems which we cannot overcome. So this is how it's gonna be. So the journey ahead of us today is 3 sections for this talk. The first thing I wanted to talk about is general idea behind the refactorings I want to show you. So what is, for me personally, the trigger when I see a smelly code? How can I make sure that this smelly code can be rewritten to a better version? So I want to share with you the thinking I'm using in order to find those pieces of code. Then we'll move to the practical side. And the first, we'll do a very simple example so that everybody can follow along and immerse in the experience of refactoring. So we'll just refactor an add function that uses futures underneath. And then we'll move over to a more involved example when we will refactor an actor system. OK, so for the first section, why? And there's a very nice paper called Out of the Tar Pit. And the guys there defined complexity as the root cause of majority problems of the problems we have in today's software systems. And by complexity, they mean basically the fact that we as programmers don't really understand the systems we write as a whole. And they defined 2 kinds of complexity. Generally, we can divide complexity into essential and accidental. Essential is what the system is at its heart, its essence, the reason for the system to exist. So everything, every function, every type that really is connected only to the heart, the real meaning of the system, is essential complexity. And all the other things are accidental complexity. So how do we store data? How do we send over data? How we share data? How we optimize things? And what language do we use? So Scala is also an accidental complexity, right? Because it's not really at the heart of the system. And yeah, there was a quiz for you, but the animations were turned off, and so there isn't any quiz for you to take. But the question was, when we have a CRM system, so just imagine that only the top of the slide is visible. And when you have a CRM system, customer relations management system, and there's a function that returns this kind of type, future of option of customer. So you know that there is a value that will be available in the future or not, then we get a failure. But if it's a success, then we have an option of customer. So the future itself is accidental. It's not really, we don't really care about it when we program our system, the heart of our system. But option of a customer is something that we really care about, right? Because we do want to know whether the customer is present in the system as a whole or not. So none or some of the customer. So this is like the basic foundation. And what's the problem here? The problem is that they are mixed together, right? So this is just one type, which mixes both accidental and essential complexity. Any questions about that? Cool. So how can we approach this problem? How can we solve this problem? And my advice would be to follow advice of smarter people. And one of them is Dijkstra, Edgar Dijkstra, who once wrote that we can just use some kind of crisp, disentangled, and simple approaches. So our code should be disentangled. That means unmixed, right? We shouldn't mix those things together, as simple as possible. So in the previous example, there shouldn't be just one type. There should be at least 2 types, right? One of them describes the accidental complexity of the things we are doing, the future, and the other one, the essential one. So whether the customer is there or not. So this is like the whole approach that we want to take. Every time you write software, do a code review, do refactoring, just please think about whether you are addressing essential complexity or accidental complexity. And just by thinking like that, you can really have some nice discussions and solve some problems with maintainability. All right. Now on to the practical part. There will be two examples I want to show you, and both of them will use the advice from Dijkstra. So the first part, there's a function, a very simple case. We want to add two integers together. One of them is locally available, so we just passed it as parameter, but the other one is a value in the future. And of course, we want to return a future of int, right? So this is like a code you can expect to have in a badly written asynchronous system. Okay, so let's implement the function. First, implement the function. Please, if you have some questions, just interrupt me. If you see compiler error before the compiler sees it, just interrupt me and let's fix it together before it's too late. Okay. So we have this add ints in future function, and what we want to do is we want to return a sum of those two integers passed as parameters. So what should we do? What can we do? Any guesses? Sorry, I didn't hear you. Yeah, we can map over them, but I would like to use for comprehension for that, but it's basically a map. So fetch from remote, right? Something like that? Is that okay? And what should I put here? Yep. Is it enough? Will it compile? OK, let's run it. And as you see, we have a print line here. And OK, so as you see, yeah, it works. Add int in the future is 5, right? So very simple implementation. What's wrong here? Sorry? There is no fallback. OK, that's one thing. But having known all the things I said in the introduction, what's wrong here? What's the essential complexity of this function that we want to write? What's the essential complexity? Adding two numbers together, right? So what's the problem? The future. Yeah, the future is the problem. And we can see why is it the problem when we want to test it. Yeah, we increase the font. So this is how it looks like, the test. So we just run this function. We pass successful future as the second parameter, and we return a future of int, right? And then we map over it, and this assertion is in the future and should be 5. So this is our test. So basically, we are running we are testing our essential complexity using futures, which are not really essential to our application. So let's change it. Let's try to be a better programmers here. OK, so let's try to abstract over the futures. So add ints in context. And there will be like a context. F, let's say that's the context that we want to add two numbers in. And we don't really care about what the context is. And fetch from context is the second parameter. Sorry, f.int. f.int. Yeah, something like that. So we don't have a future here. What we say in the signature here in the function, we say that the int can be in some kind of context. So what's the implementation here? So can it be fetched from context? Can we use something like that, the same approach? What do you guys think?
No.
Why not?
No flat map on fetch. You make it more not.
Yeah, but flat map or map?
Flat map here.
Why? So what kind of type class should we make f implement in order to be able to use this add in a context function? Functor. Yeah, functor. So right now, it should work, right? Just I'm uncommenting the second thing. So this line, what it says is that we just wait for the future. So as you see, we are using future only in this part of the program, right? So the other way, the other part of the application, the client part of the application, and this one is our logic, business logic. It doesn't really care about f. The only thing it cares about is that it needs to be a functor because we need to map over it, right? And this is the only thing we want to do with it. So we really can pass anything that is a functor. So let's try to run it and see what happens. Yeah, as you see, there's also a second line. Do you know what's the shortcut to increase the font in IntelliJ? Okay, I will do that over and over again. So it works, right? It works. The implementation is very similar. But I want to also make sure that if we can implement, we can add many other things, not only ints, because it's just adding stuff, right? So whenever something can be added, then we can reuse it, right? So let's try to do that. Add in context, and I will need some of your help here. So I will need a functor here and a type A, which we want to add. So start thinking about what we are missing here. Anybody knows?
Some evidence that you can add A.
Sorry, I didn't hear.
Some evidence that you can add A.
Yeah, I will. So I can fetch from context as we did before, and I want to yield local plus fetched. So what the compiler will say in this situation? As you see, it's highlighted. You won't see it, but it says type mismatch expected string, actual A. So yeah. So we need an evidence. What's that evidence in functional programming world? Sorry? No, it's a type class. So yeah, if you provide instance of type class, it's the evidence, right? So what type class implements? So what type class makes the type implement adding functionality? Numeric. That's right. Very good. So right now we provided an evidence that A should be an instance of type class numeric, and as you see, the plus operator is now very nice and blue, and this should also work very fine. So I'm commenting this double adding functionality, and when I run it, it should also say 5.0. Okay. Any questions about that?
I have a question.
Yep.
Why do we have 5.0 if we just add ends?
So in here, this third line, we are adding two doubles.
Okay, so
2.0 and 3.0. Cool. All right, so let's move on to tests, right? So right now we have three functions that are, in my opinion, I don't know about your opinion, but in my opinion, are better, far better. Even though they look very similar, they're far better than this one, which the only difference is that we are not using ints and futures because we really don't want to use them. We want to use as smallest possible type as we could, right? We need to restrict ourselves as much as we could in order to make other guys more free to use our functionality. Okay, let's try to implement a test for the new two new functions that we written. Okay, can you see it, or should I make it even bigger? Okay. So the tests are very nice when add ints in context should return 5 when adding 2 and 3 in a context. Do you have an idea how should we approach this? So we should maybe call something. Let's call our getting rid of future add in context function and add 2 and 3 together. What do you think about that? The only thing that's missing here is the context in which we want to add those two things. What do you suggest? ID can be a nice one, right? So does it work? Yes or no? So what should I put here? Should be what? Result should be what? 5. So will it work? Who says it works when I run it? Only 2, 3, 4, 5. Okay. We'll see. Let's run the test. Yeah, it works. So what's the type of result then? How is it possible for it to run and execute properly? What's the type of result?
Numeric.
Sorry?
Numeric, I think.
No, sorry? Int. So when I put int here, it should work. Okay, let's run it again. Yes, it works. But how is it possible that we return f from f int here?
Because I define it as.
Sorry?
Because I define it that way.
Yeah. So when you see ID, and it's just I will show you the line in a minute. I'll just make it bigger. This line here, type ID of A is just A. So it really doesn't matter. It really doesn't matter what we put here, if it's int or ID of int. So both guys will work fine. Okay. So this will also compile and run fine. Okay. The second test is very similar, but we use ID and double. So I won't show you this one. Okay. Any questions about this very simple example? Yeah, please.
What if you want to simulate situation in which you have failed future?
What? Future is what kind of complexity?
It's accidental, but still, sometimes you want to test it.
Yep, and I'm just showing you unit tests for your essential complexity. You can also have a test for failing functions, failing futures, or failing actors, messages that are not delivered, things like that. But this is the other part of the system. You should test it probably in a different way, not really as a business logic unit test. Okay?
Okay, so we just test happy path here and we'll test another.
It depends on what you mean by happy path. So.
Yeah, I mean the right path.
So essential thing for our system here is to add stuff together, right? And the accidental ones should be tested separately. That's the approach, okay?
I think it depends what you would call the essential complexity. Sometimes being remote is essential complexity,
Yep.
complexity, not the accidental.
That's correct. You're right. It depends on the system, right? You're rating.
It depends. It always depends.
Yeah, that's true. Okay, and second example is more involved one. So we have an existing actor system, and who? Yeah. So.
Because you say there's the essential and accidental complexity.
Yep.
And you actually say that you got a function that the possibility of this function is to add numbers. So actually we better to the factor is to get the function that adds two numbers and move this forward future key outside of the function.
Yeah, that's actually what you need then in order to use it. You'll need somehow to wait on the future, right? Before you move on. So the idea is that
Right. In like functional languages, you can just leave both parameters to be this like future in this context and just run this function inside of this context. So you
Yep.
get this.
that's correct. That's what we are going to do next also.
It's kind of the next step.
Yeah, probably. This is just like a mechanism that you can use, right? You still have many tools in your toolbox. You can do it differently. This is just one way. All right, so the second part is an existing actor system, and who of you knows akka or did some akka stuff in the past? Or Erlang, whatever, okay. 1/3 of the room, okay. So there are two actors, basically. The yellow ones, we can't touch them. So palindrome checker is the guy who receives a string and returns a Boolean value to the sender, saying whether it's a palindrome or not, the string that we received. And the length calculator returns length of the string passed to this actor, and it returns it to the sender. And what we want to refactor in this refactoring step, so we don't want to touch the yellow ones in this refactoring step probably. We treat them as external stuff. What we want to do here is we want to refactor this string stats calculator actor. What this actor does, it really just constructs string stats case class, an object that contains both information. Is it a palindrome, and what's the length of the string? And yeah, we want to replace this actor with something more maintainable. So let's see how the system looks like right now. Okay. So here's the classic approach. So the existing system looks like that. So we have a external stuff first. String stats is the thing that we cannot touch, length and palindrome, as I said. And there are two actors that are already defined. We won't change them. The first one just returns a length of the subject that was passed, and the second one returns a Boolean value, whether it's a palindrome or not. So those actors are just implemented, and we can't touch them. We can just use them, and we should still use them. And the string stats calculator actor, which is the one we want to somehow refactor, is the guy who takes both actor references in the construction phase, and then whenever it receives a string, it asks length calculator about the length. So what's the type of future length? Future of int. Then it asks palindrome checker about the same string, maps it to Boolean. So what's the type of future palindrome check? Yeah, and then we just do a for comprehension and yield string stats with length and palindrome, right? So what's the type of future stats? Future of string stats, yeah. And what we need to do here is we want to send the string stats back to the user, right? So we just close over the sender, and its future stats is just a future. So for each value here, we just send back to the sender. Okay. So this is how it looks like, and it should work fine. So let's run it, and there will be an exception because we still haven't implemented the new approach. You see, not implemented here, but the first line in our console output should show that we have really run it properly. So as you see, classic approach, string stats for ABBA is string stats for and true. So this is what we have right now. And so this is the actor that we want to refactor. Any questions about this actor before we move to the refactoring step? Nobody? Okay, everything's clear. Very cool. So functional approach. Before we move on, I want to show you the tests for this actor, right? So test kit library. This is what we use in order to test actors, and this is how the test would look like in a normal standard akka application that uses test kit as unit test library. So we really don't care about length calculator and palindrome checker actors. We mock them, and test probe is just a mocked actor that we can manage. And under test is what is the actor that we want to test. In this case, it's string stats calculator, right? So what's the essential complexity of this actor? It's just creating the string stats object, right? So it's also very simple. It needs to gather the data from the outside world, and really what it does, it constructs a string stats object. So what we do here is we construct this real actor, but we pass mocked length calculator and palindrome checker probes. Then we send ABBA to this under test, and we expect in those probes two messages, right? So length expects ABBA and replies with 4, and palindrome checker expects ABBA and replies with true, right? So mocked responses. And then at the end, we just do a final assertion, which is we expect that we as a sender, we send the message here, and it triggered the string stats to be sent back to us, and with the length 4 and palindrome true. And this test works fine. So this is how the normal AK application can look like whenever you mingle the business logic or the essential complexity with accidental complexity. In this case, the accidental complexity is just sending messages around, right? So the communication phase. Okay, let's move on to refactoring. What we'd like to have, really, is we'd like to have a function, right? String stats function, ideally. It should get some functions that are their dependencies, dependencies. So calculate length is one function. Let's say it's string to int, right? Check. Okay. And check palindrome is the second function that we want to have here. String to, who pays attention? Everybody. Cool. Boolean. And what it returns is another function, string to string stats. Let's do it this way. This is a cool approach, right? And for comprehensions to the rescue, what's really a function? Who knows? What function really is? Can we do something like that? Length and calculate length. Is it okay? Is palindrome? Check palindrome. Is this cool? Yield, string stats. Guys, come on. What's happening? What? Is it okay? Is it compiled? Oh, let's we don't have to use those actors yet. As you see, they are highlighted. We can just check how this function really works. So stats function is string stats, and let's just try to pass like this function and this kind of function. Okay, yeah, it works. So what's the type of stats function? Who knows? Is it the function? Yeah, I named it function, so probably it should be a function. You can see it, but yeah, it's a function from string. I will just write it here. From string to string stats. And it compiles. So we can just comment this out and comment this out and just return stats function and apply subject to it. Right? Subject is how we run the whole application with the string that we want to calculate the stats for. And should it work, in your opinion? Let's look closely. I'm running it. What the heck? Yeah. So it is fine. What happened? Sorry? Yeah, that's the problem. We want to address it later. But how about this string stats function? Is it okay to do a for comprehension and use functions as some kind of monadic values or maybe functors? What's really a function? A function is a value inside a context or inside a container, right? What we need to do in order to get the value from the container? What we need to do in order to get the value from the container? Who knows? Sorry? Yeah, we need to apply an argument, right? And then we get it out of the context. So this is what's happening right here. We are using cats library, and so yeah, that's the magic where magic happens. Yeah, so really function is a functor. So what we are doing here is really we are saying that no matter what string is, when you have the string, you can call it, right? You can apply it. But we don't really care about the string right now. We just care about composing those functions together. So we are composing calculate length and check palindrome in order to produce string stats. Is that okay? What do you think about that? Cool? Okay, but the problem still remains, right? So we don't have anything, we haven't really used the actors, though the results are correct in this case. Okay, let's move on then. What we really need is we don't have a plain functions, right? So what actors do when you ask them, as you said, as you've seen before, they return futures of something. So we need to have a future here, but we learned something before. Let's not do this from the beginning. Let's just reuse the knowledge we already have. So let's do a f calculate length is a function that takes string and returns f from int. And check palindrome is a guy that receives string and returns boolean. And here we want to return a function that gets a string and returns string stats in f context. And now we get compilation errors because really this kind of functions that return monadic values are not composable. So what now? Fortunately, I have already imported cats library, and this kind of string, this kind of functions, string or any type to a type in a monadic context, they are, who knows? Sorry? Yeah, Kleisli, but let's not say it out loud here. Reader T, okay? Reader T. Reader T is the data type from cats library, or not from cats library, but it's a data type that what it does is just represents the function that returns a monadic value. And it has three data types, as you may have guessed. F is a context, and a string plus int. So those two here are the same thing, with one additional value, with added value from reader T. Reader T's are composable. So this is what we gain. So calculate length is a reader T, and check palindrome is also a reader T. So let's do it. What should I put here? F? String and boolean. Yep. And also the return type, reader T. Sorry. Yep. Okay, and I'm missing a comma here. That's why it doesn't compile. And now it compiles. Okay, so it works. So we now are still composing the same functions, calculate length and check palindrome, in order to get string stats. But now those functions also can return monadic values, which they really do, because we are targeting actors, right? In the end. So what we need to do here is we need to help the compiler compile this thing. So the functions will remain the same, but we will do future and string int. And the second one will be reader T future, and it won't compile. So you can start thinking about what we need also to change in order for it to compile. those two, for and true, are highlighted. Why do you think is that?
So it needs to be backed in future.
It needs to be backed in future. Cool. Thank you very much. Successful. And this is application, right? So we just reuse string stats. String stats doesn't know anything about futures, but we still can use it with futures. Okay. And what's happening here? Sorry? Return type, yeah. So what should be the return type then? Reader T. Okay. So far so good.
Future, string, and string stats.
Yeah, it compiles. But so if the return type of this one is reader T, can we really apply something to it? What do you think? Stats function is a reader T, right? So what reader T right now is just a composition of functions, right? We haven't really provided any string yet, right? So reader T has something like run, and we can provide us the thing here. But what do you think run should return? What should be the return value of run?
Future of string stats.
Sorry?
Future of string stats.
Yep. So what it really is here. So it's future of string stats. And right now we can just await as in normal future, and when I run it, hopefully it will compile. No, it won't. Why? I won't increase the font here. Who knows? Sorry? Yeah, that's it, right? So I need a monad instance here, and now, why? Sorry, why do we need a monad instance here? Sorry,
Because reader works on monads, it's monad
because of flat maps, basically. We could also use flat map because in cats there is a flat map type. I don't want to go into this direction right now, but just so you know. And yeah, let's run it. Should be perfectly fine. So we still get the same good results. But what's still missing? What we are still not doing? The actors, right? So we still haven't really touched actors, and this is the whole thing. So yeah, it's only 3 lines away. Really, you need to believe me. So I want to define an ask actor function, which is a pretty generic one. It gets 2 type parameters, Q and A, like question and answer, and it receives an actor ref. And I want it to be used as a calculate length and check palindrome parameters. So what kind of types I should? Future, right?
QA.
Future QA. Okay. So Q is here's a function that I'm providing. Q is a question I want to ask the actor. So I'm asking the actor the Q question, and I will wait maximum 1 second, and I will map it to A. So this is the function. And I have a function right now. What I can do is I can just use it. Ask actor length calculator. I just move it to the next line. And ask actor palindrome checker. Is that all? Yeah, seems like it, right? So if I run it, it should be executed correctly, and we'll receive the right answer or not. I know it's a trick question. Sorry about that. It won't really compile because of the A type here. Right, the type erasure comes in, and in here it doesn't really know what A is, so we can really very quickly repair it by adding class tag instance here, right? And now it should work fine. So any questions about that any questions about that before we move to tests? So it works fine. We are using actors. Our string stats function doesn't really know anything about actors nor futures. We are composing two functions together that can return monadic values, and that's the way it is. Any questions about that before we move on to tests, which will be very simple, as you may expect? No questions? Okay, let's increase the font in tests then. So there will be just one test, because what we really done is string stats function, and what it should do, it should return string stats for Abba. Let's say it like that. And in value, so result. No, first mocked functions. So we are mocking two functions: length, calculate length, and check palindrome. So mocked calculate length is a function. It's a reader t, right? So it's a reader t of what kind of context?
ID.
String.
String
and int. And the function will always return 4. We can do like that, something like that. Mocked check palindrome. The reader t of ID string boolean, and it returns true. And now we can really call our string stats function. So result. Let's go here and import it. Import asking actors functionally, functional approach string stats. And yeah, result string stats, mocked calculate length, mocked palindrome check. And what's the return type of string stats? Who remembers? What's the result here? Sorry? Reader t. So what should we do in order to really check run with what? Look at the description of the test. Yeah. So what's the type of result now? Why future? Yeah, it's just string. String. It's just what? Sorry.
Idea of string.
String. Are you sure that's
Idea of string or string?
stats?
Oh wait, stats.
Yeah, I know.
Idea of stats or
Yeah, so string stats with length 4 and palindrome true, right? So this is the test. So we are really testing the essential complexity thing using ID context, which is an ambient Scala context, right? Yeah. Okay. And then we can just run this test, and it's green. Any questions about that, about the test? So you can compare what we needed to do here, and we are using real actor system underneath, so it's a little bit slower than this one. This is just function calls. Okay. So this is the whole talk. Thank you very much. Are there any questions?
Maybe I have a question. There was a lot of places where we need this timeout. And what is your general advice to how we can easily avoid the asking and timeouts? How we deal with it?
Yeah. So asks. Generally, the advice would be to not use actors whenever you want to ask about something, right? So you need to use futures when you want to ask about something that is like on the remote server. So fetch from something, and you will need timeouts in order to do that. There's no other way around, right? So the real problem is what's the good value in terms of the system you are writing, And I don't have an answer for this question. It really depends, and I don't even know if we have figured it out in our system yet. So the numbers themselves. So if there's something on the remote server, you need to fetch it over the network. You need to have some kind of timeout. Sorry. Yep.
Can we do this example without importing this cats library? Because I'm not familiar with that, and I got lost a little bit at that point.
Sorry about that.
No problem, but can we do it without the cats library? Okay.
Yeah, you can do many of those things yourself. When you see, for example, how CATS implements it, there's a lots of boilerplate in the library itself, so that we don't have to do it, right? So the code looks better. And my advice would be just to get accustomed with those. Not use them maybe, but if you don't like them, don't use them. But just try to learn about those things. Maybe see the code. I will post it together with slides. Try to go through it again, and maybe those reader T's and option T's and other things will get more familiar to you, and it will be just like ints and floats and classes. Yep.
One question. We use this F type everywhere where we can because we don't want these features to use it explicitly. And how often do you deal with that you really replace the future with something else, and it is really worth to have this, say, extra complexity? Because I see the tests are simpler, yeah, but generally, what the advantage of it? If you are still using future rather than any other.
So the main advantage, in my opinion, is just the code is more readable this way. I know this is like a personal opinion, but the future is something that you don't really care in this unit test. That's why you just abstract it away and just say, I want something to be a type that can be mapped over itself, right? And so getting rid of future, you don't. If you get future in your function, you can do future things with it. If you don't get future in a function, you can't do future things with it, right? So you can't really do any pattern matching on it, right? You can't really wait in your function. There are people that wait for the future to complete, right? So when you abstract it away, you just don't give any reason for it to be used, because you don't want it to be used there. Okay, does it answer your question?
Yes.
Okay, thank you. And more questions? Okay, thank you very much.